Hi friend, Pradeep Vaikar is here. Welcome to my channel Stampsbee. This is truly free knowledge and experience sharing channel. On this channel, I am going to share my experience in stamping industry. To achieve the business goal, every engineer wants to strengthen, sustain and enhance the desired performance of the draw operation. But how to achieve the desired performance of the draw operation? Is any assessment tool is available for this? The answer is yes. The key assessment tool for this is a gap analysis. This tool guides you on how to conduct step-by-step assessment of the entire operation. It shows area and element-wise gap. Once the gap is identified, you need to look into why the gap is exist and what you can do about the gap. Corrective actions can be implemented by conducting cost study and priority setting. After setting the corrective action, the effectiveness of the operation can be reviewed and analyzed. Gap analysis helps you to balance and allocate the resources. And friends, I have practiced this tool in sheet metal draw operation for more than 20 years in stamping industry. During this period, I have identified 8 critical areas of draw operation. To share my experience, I am going to release series of the videos on draw operation gap analysis. It consists of discussion on critical area and standard gap analysis template for 5 areas. This series is going to clear all your doubts on draw operation gap analysis. And friend, if you have joined this channel for the first time, please subscribe to my channel and press bell button. Also like and share this video with your friends. It will motivate me to make more and more videos. Come on friend, first we will understand 8 critical areas of the draw operation. Following are the critical areas of draw operation gap analysis. I am going to release separate video for each area. First we will understand each area. Area number 1 is understanding the gap analysis model, tip draw operation, standard gap analysis template for draw operation and sheet metal formability. Area number 2 is introduction to draw die element and desired function of each element. Third area is stamping press important parameter, their desired standards and gap analysis template. Fourth area is production setup approval, its desired technique and gap analysis template for setup approval. Fifth area is draw shell common visual defect, their recording technique and defect relationship with the process. Sixth area is draw die preventive maintenance and history recording, gap analysis template for die preventive maintenance. Seventh area is draw die correction and refurbishment, gap analysis template for draw die correction and refurbishment. Last area is consistency in draw operation performance and understanding the consolidated gap analysis template. Without any further delay, we will start first session of the gap analysis series. First, we will understand what is gap analysis. Gap analysis is a method of comparing current state of part, process and services to desired state and determining the step that must be undertaken to improve the current state. This is the general block model of the gap analysis. Here is the start point. In first block, organization goal is defined. In second block, the contributing areas and elements are recorded. In third block, desired or approved state of each element is recorded. In fourth block, the current state of each element is recorded. In fifth block, the comparison study of desired state and current state is recorded and gap size is identified. Sixth block is for cost study, priority setting and action planning. Last block is for analysis, effectiveness measurement and review. This is the end point. If the achieved state of the process is not up to the desired state, in that case the whole cycle is repeated once again. Now we will understand actual block model for deep draw operation and standard gap analysis template for deep draw operation. This is the general block model for deep draw operation gap analysis. Below given template is derived from above block model. Operation areas and elements mentioned in the templates are identified on fishbone diagram under the framework of 8 M's. In column number 1, organization goal is mentioned. In our case, improving the performance of the draw operation is the organization goal. In column number 2 and column number 3, process critical areas and elements are mentioned. In column number 4, desired state of each elements are mentioned. These elements and desired states are identified with reference to Indian standard and work experience. The user of this template has to record current state in column number 5, comparison study in column number 6, root cause and priority in column number 7, and last column is for measurement and review. Now we are going to discuss deep draw operation to bring all viewers in one platform. Here we will understand deep draw operation. The deep draw operation is a sheet metal forming process in which flat sheet metal blank is radially drawn into drawing die by mechanical action of blank holder and draw punch. Figure 1.1 shows the stages of the draw operation. In stage number 1, die element like punch, blank holder and die cavity are shown. First, the blank is loaded on the die cavity and held with the help of blank holder by applying uniformly distributed load on blank holder. Then punch advances with specified load and speed. The draw punch completes the operation by stretching input material into die cavity up to the end position. In this way, the sheet metal blank is given shape of die and punch. In all above stages, the load applied on the blank holder and punch are the topmost critical parameter. Thus, drawing is the form transformation process by stretching the input material from elastic zone to plastic zone to retain the form shape. The performance of the draw operation depends on the process parameters and the formability of sheet metal. Now we will understand the formability of sheet metal. Here we will understand formability of sheet metal. Formability is the ability of given sheet metal to undergo plastic deformation without any defect such as crack, necking or fold. The formability of sheet metal depends on mechanical property of input material. Here we will understand some of the mechanical property of ductile metal on stress strain curve. Figure 1.2 shows the stress strain curve of ductile metal. In this, stresses are recorded on y-axis and strain are recorded on x-axis. This curve has 4 significant points. Point number 1 is proportionality point, point number 2 is yield point, point number 4 is ultimate strain point, and point number 4 is rupture point. These 4 points divides the whole curve into 2 zones. First zone is elastic zone and second is the plastic zone. Curve from origin point to proportionality limit point shows that stress is proportional to strain and it has a linear relationship with them. The change in dimensions are reversible after removal of the load. Curve from proportionality point to yield point shows that the proportionality of stress to strain has lost its relationship. Changes in the dimensions are still reversible after removal of the load. Curve from yield point to ultimate strain point shows that stress is increasing drastically with less increase in strain. Changes in dimensions are not reversible after removal of the load. Curve from ultimate strain point to rupture point shows that stress is not increasing but strain is increasing radically in this zone. At particular point, material get rupture. Friends, the performance of draw operation depends on stresses which are induced on the drawn shell against the stresses for which the part is designed. Now we will understand the surfaces of draw shell and stresses induced on it during the draw operation. Here we will understand stresses involved in cup type draw operation. Figure 1.3 shows cup type drawn part and its half section. In half section, three surfaces are visible: flange, wall and bottom. Flange surface involve tensile stress acting at the center of the cup and compressive stress acting in circumferential direction. Due to biaxial stresses, maximum friction is taking in this zone. This is the surface which is most sensitive in terms of quality defect like wrinkles. Wall surface involve uniaxial tensile stresses and bottom surface involve uniaxial compressive stresses. The radius zone joining wall and bottom are subjected to compressive stress at one end and tensile stress at another end. Due to this condition, this is the most sensitive surface in terms of quality defect like necking and cracks. Now we will understand the stresses involved in box type drawn operation. Here we will understand the type of stresses involved in box type draw operation. Figure 1.4 shows the box type drawn part. In plan view of part, two types of surface visible. First one is corner radius at 4 places and straight portion between the radius at 4 places. Stresses similar to the cup draw operation are involved in all corner radius, and stresses similar to bending and strengthening are involved in straight portion. Drawing corner radius and straight portion together is a complex material flow. The ratio of corner radius to longest side and the ratio of component depth to the longest side is maintained in part design to achieve the maximum stress within the permissible limit of the stress. Friends, now we will understand mechanics of sheet metal forming in simple word. First, load is applied on sheet metal plank. The applied load develops deformation of the material grain. The deformation of material grain induces internal restoring forces that is known as the stress. The stress results into elongation and strain hardening of the grain. The strain hardening develops dislocation of the grain that is known as the plastic deformation. And plastic deformation of the grain under the mechanical action of draw, punch and die is known as the draw operation. This is the last topic of the today's session. Friends, in today's session we have covered the first area of the gap analysis series, that is understanding gap analysis model, deep draw operation and standard gap analysis template for deep draw operation and sheet metal formability. Please write your comments and suggestions in comment section. You can connect me on below links. Thank you for watching today's video. See you again in the next video of gap analysis. Bye bye.